Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the electrophilic center. NaBr is a source of Br, a nucleophile. In an S_N2 reaction, Br attacks the carbon bearing the tosylate, OTS, leaving group, which is C1, the benzylic carbon bearing pH and OTS. Step 2. Determine the configuration at the reaction center. S_N2 proceeds with inversion of configuration at the carbon under attack, C1. The OTS group is on a wedge, coming toward the viewer, meaning it occupies a specific spatial position. Br attacks from the back face, anti to OTS, resulting in inversion. Br ends up on the opposite face from where OTS was. Step 3. Identify what the product looks like at C1 and C2. The C2 center, bearing CH3, H, co-to-me, and C1, is not attacked, its configuration is retained. The product is PHCHBrCH, CH3, co-to-me with inversion at C1. Step 4. Analyze the relative stereochemistry in the product. In the starting material, the wedge on OTS, C1, and the bold bond on CH3, C2 indicate a specific relative configuration, anti or SYN. After inversion at C1, the relative configuration between the newly introduced Br and the CH3 at C2 changes. The starting material has OTS and CH3 on the same face. Both bold wedge is equal to SYN, so after inversion at C1, Br and CH3 are on opposite faces, anti. Step 5. Match to answer choices. The product drawn in option A shows the 2-carbon fragment, now without pH, focusing on the ester portion shown, with H3C and Br in an anti-relationship, H3C on one horizontal, Br on the opposite horizontal of the lower carbon in the Sawhorse Fisher-like representation. This corresponds to inversion at C1, giving the anti-diastereomer with respect to CH3. Step 6. Eliminate other options. Options B, C, and D either show the wrong regiochemistry, attack at C2 instead of C1, retention instead of inversion, or the wrong relative configuration of Br and CH3. Therefore, the correct answer is A. Therefore, the correct answer is option A.